Okay, so this first problem says the graph shows the rate of reaction of enzyme X as substrate concentration is increased. So it looks like as substrate concentration goes up, so does enzyme reaction rate. It does level off here at about 37 or so percent, probably because an enzyme can only handle so much substrate at once, right? But it says, suppose that you introduce a competitive inhibitor into the solution with the substrate and enzyme X. Okay, competitive inhibitor. That's definitely something I remember us talking about the other day. So I think I'll go back to my mind map that I made right here. And yep, there it is. So let me see if I can zoom in here. It says competitive inhibitor. A substance blocks the substrate from getting into the active site, which slows down the reaction rate. Okay, slows down the reaction rate. It says it gets into the active site. So, if I want to show this reaction rate slowing down, I probably should have it not reach 37%. I should probably have it reach lower, maybe somewhere around 30 or 25%. So it says draw what the new line on the graph would look like once the competitive inhibitor is introduced. And I'm supposed to use the scribble function, which is right up here in this whole menu. The scribble is the bottom one. So I think I'll have it start in the similar spot just above 0. And then it's going to increase, but it's not going to increase as fast because that competitive inhibitor is blocking the active site. Okay, my line's not perfect, but that's okay. So let's explain what I mean here. So I think that the reaction rate will be slower because the competitive inhibitor is blocking the active site of the enzyme. This means that the substrate cannot attach to the enzyme in order to be worked on, either being built into something or broken down. I'm not sure which one. Okay, so yeah, ultimately, when you add a competitive inhibitor, you're going to see a lower reaction rate because that active site is being blocked on the enzyme.